This video will discuss MGSE7 EE3, solve multi-step real-life and mathematical problems posed with positive and negative rational numbers in any form, which includes whole numbers, fractions, and decimals, using tools strategically. Apply properties of operations to calculate with numbers in any form, convert between forms as appropriate, and assess the reasonableness of answers using mental computation and estimation strategies. In elementary school, students solve multi-step word problems involving whole numbers only. They represented these word problems using equations with a letter standing for the unknown quantity. They also assessed the reasonableness of their answers using mental and computation strategies. By sixth grade, students begin to fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm for each operation. During the rational numbers unit in seventh grade, students solved problems with rational numbers. For 7EE3, students solve multi-step real-life and mathematical problems with positive and negative rational numbers. When solving, students convert between numerical forms such as fractions, decimals, and percentages. Students use estimation strategies to assess the reasonableness of their answers. In the concrete stage of instruction, of the concrete representational abstract phases of instruction, each mathematical concept is modeled with concrete materials. With this standard, students can use Lincoln cubes, Cuisenaire rods, algebra tiles, or fraction tiles to model multi-step problems. Watch as this student uses Lincoln cubes to think through this problem. Jamie has 60 flowers. She plants 80% of the flowers within her garden. How many flowers does she plant within her garden? What did you say this was worth? What did you say this was worth?
3.
Why'd you get 3?
Because 30 is half of 60.
But the whole thing is 60, so then this first one needs to be how much?
6.
6.
6 times 6 times 8. 6, 12. 6, 12. 18, 24. 30, 36, 42, 48. So it's 48 flowers.
As students transition from concrete to representational, they may begin to draw tape diagrams to mirror the concrete materials once used. They may also use drawn models and sketches to represent the situation. In this clip, the student will explain how she divided a square-shaped bookstore into 4 equal parts. Knowing a triangle is half of a square, she was able to determine that the area of the triangular cafe is actually half of 1/4 of the total area of the bookstore.
I split it into 4, and then it was 144 each square, and then I had split it into 2 because a triangle is half of a square, so it came up to 72.
Interesting. So you took the 576 and you divided it by 4? And so this part in here you said was how much?
Each square is 144.
Each square is 144. And then what'd you do with the 144?
I divided it by 2.
I like that strategy. As stated in the standard, students convert between the forms of numbers, fractions, decimals, and percentages as appropriate. Questions such as this one require students to convert between numbers, deciding which form of the number in which they want to work. Students can convert the fraction to a percentage or the percentage to a fraction. For the shrinking task from illustrative mathematics, students must determine the height of 2 different women at 2 different ages. Students are provided with the following information. When working on a report for class, Katrina read that a woman over the age of 40 can lose approximately 6/100 centimeters of height per year. Students may use their proportional reasoning background from 6th grade or other strategies to solve both parts of the task.
So in order to convert
centimeters in the inches, we need to do 0.06 centimeters divided by 2.54. Just divided by.
You have to centimeter height decreases after age 40. About how tall she be? She's 65. So you're supposed to do 25. No, you do 5. Okay, you have to convert the inches to centimeters first. So times 25 equals 0.5.
Where you get 25? Oh, I see.
Yeah. Okay. So and then we were thinking for this, we don't have any
Have you
centimeters.
figured out how tall she'll be at age 65? Was that your last step?
Oh. No. Multiply difference by inches. Okay, and then we subtract. Okay. What do we subtract? Do we subtract the?
What does this tell you?
This tells
The 5/10.
how much weight.
How much she's losing?
How much what she's losing?
How much height she's losing.
As students work through multi-step problems, it is important for them to make sense of the quantities within each step of the problem. In this clip, the student needed to understand that 5/10 represented the amount of inches lost after 25 years for Katrina's aunt. That quantity needed to be subtracted from Aunt Nancy's original height of 5 feet 7 inches. Percentage problems do not only appear within the proportional reasonings unit for Georgia. While working on the standard, students can be provided with percentage problems along with various strategies for solving them, as seen here in these tasks from New Zealand Math's Numeracy project. Having students analyze each strategy and discuss what happens to the original or cost price will aid in the use of multi-step equations to solve percentage problems.